Hybrid search breaks when the scores do not mean the same thing. OpenSearch search pipelines let you normalize retrieval signals before the reranker sees them. You'll learn the shape of a workflow that balances lexical and neural scores and re-ranks the hybrid results. I'm Professor Pi, teaching search and IR with simple Python. Hybrid search is a familiar pain. BM25 will light up on exact words. A vector model will pull in semantically related content. The trouble starts when those two scores live on different scales. They don't add up, they fight. We want a workflow where a re-ranker can trust a combined score instead of being steamrolled by one source. Normalization is the simple idea that fixes the currency mismatch. Think of it like converting dollars and euros before you add them. Here, we squash BM25 spikes and rescale vector distances so both signals sit on a shared range. The payoff is cleaner re-rank decisions. The risk is obvious. A heavy-handed normalization can erase useful differences, so we keep the steps simple and explainable. We will build a tiny pipeline in OpenSearch that indexes hybrid docs, runs a hybrid query, registers a normalization processor, and then re-ranks with the normalized scores. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we need an index that holds both text fields and vectors, so hybrid queries can run confidently. This snippet bootstraps an OpenSearch index tailored for hybrid scoring experiments. Engineers worry about whether their cluster can hold both BM25 text and vector shapes, so we first call OpenSearch against localhost and wipe any leftover index named docs via client.indices.delete. The schema dictionary passed to client.indices.create explicitly enables index.knn and defines the text field beside a knn vector dimension that matches later query vectors. Seeing index ready true tells us the cluster accepted the mapping and is ready to score lexical and vector clauses on the same data. Now, we must populate that index with documents that mix text and representative vectors so the misalignment shows up. This example loads 3 representative hybrid documents through opensearch-py's bulk helper. The bulk call keeps ingestion latency low, while guaranteeing each record carries both a text string and vec values, so engineers can replay the same scenario that sabotages lexical-only scoring. Refreshing the index with client.indices.refresh forces visibility without waiting on automatic refresh cycles, which is critical before querying in tests. The docs indexed equals 3 print shows the cluster acknowledged every document we need for later normalization experiments. With data in place, we should run a hybrid query to see how BM25 and KNN scores disagree in practice. This code fires a hybrid query so you can inspect how BM25 and KNN scores misalign. The shared query dictionary mixes a match clause and a KNN clause targeting vec, mirroring the hybrid syntax that often yields wildly different score ranges. We immediately pull hits from client.search into a Python list so you can round and view the raw underscore pairs without extra tooling. Observing raw scores with one document far above the others explains why naive re-rank steps often promote lexical hits and bury semantic matches. Seeing that mismatch, we register a pipeline that normalizes both clauses before any re-rank logic runs. This snippet registers an OpenSearch search pipeline that normalizes hybrid scores before they reach re-rank logic. The pipeline body payload adds a normalization processor with min-max normalization and geometric mean combination so lexical BM25 spikes lose their dominance, while vector hits gain calibrated weight. Client.transport.performRequest binds that configuration to the hybrid norm pipeline ID without needing a future client release. Pipeline ACK is true proves the cluster accepted the processor, unlocking consistent score ranges for downstream rerankers. Finally, we run the same search through the pipeline and apply a simple rerank to validate the effect. This example executes the hybrid norm pipeline and applies a lightweight rerank to show why normalization matters. Adding query size and the params search pipeline flag keeps the open search request identical to earlier tests, while forcing the new processor into the path. The loop computes a tiny lexical overlap bonus, so you can imitate a cross-encoder stage that trusts normalized score as a base signal without writing external service calls. The re-ranked IDs list confirms the balanced scores allow Doc2 to surface ahead of the BM25 heavy Doc1. In short, this small flow is the practical checklist. Index your corpus with text and vectors. Run a hybrid query to spot score imbalance. Register a normalization pipeline. And then re-rank using those normalized scores. For real projects, you'd replace the toy vectors with real embeddings. Use an ANN index and monitor timing and rank metrics to be safe. Recap. Normalize hybrid scores inside OpenSearch so a re-ranker sees comparable signals. Use this when lexical and vector scores compete and you want predictable re-rank behavior. One caveat: normalization changes relative signal strength, so validate you're not removing valuable differences. Next step, try tuning the normalization method or parameters. For example, swap min-max to z-score, or adjust the geometric mean weights to bias lexical or semantic importance. If practical, hands-on IR helps your projects. Subscribe and watch the IR videos.